Hey everybody, this is part 2 of the unit circle. This should be a faster video. A lot of the concepts that we had to kind of develop from the first one, I'm just going to bring straight over from the first video into this video. We won't have to redevelop those. Things like moving across the axis is just going to be a negative instead of a positive. That being said, let's get into it. So on our other circle, the ones where we chopped it up into 30 degrees, we're going to be using that 30, 60, 90 triangle. Okay. Now on this 30, 60, 90 triangle, we need to make sure we're labeling our sides correctly. So again, it doesn't really matter which one you use. This is going to be 60, though, because it's definitely the bigger angle, and this is going to be 30. Okay, again, I would pick one. Let's go with 60 for right now. Okay, so on my 60, and I'm going to use strictly black here because we're going to be flipping this triangle around and kind of messing with it a little bit. So depending on what your reference angle is, it will change which colors you would want. Okay, so I'm not going to use the colors for right now. We'll use them when we actually add them onto the circle. So this is going to be my opposite. This is going to be my hypotenuse, which is still 1, right, because we're putting it on the circle. And then down here is going to be my adjacent. Okay, just for funsies, let's see if we plug these things in, if they work out nicely for us. Okay, I'm going to call this a PP just so there's no confusion in a second. Okay, so let's try the sign of 60 equals the opposite over the hypotenuse, which is just 1, multiplying by 1. Really is not going to change anything. Let's throw in sine of 60, just see what happens, just see if we get a nice number. Because last time we tried this, we got, those 0.707s. So let's try sine of 60, see what happens. So unfortunately, we get another kind of gross number. Let's try adjacent, just to see, because definitely the sides are different here, right? Because it's not an isosceles triangle. So cosine of 60 equals the adjacent over 1. Again, multiplying by 1, not really going to do anything. And then cosine of 60. Okay, well, cosine of 60 turns into 0.5. That's really nice for us. Let's, frac that. You should know what that is, but just in case. So our adjacent down here is going to be 1/2. Move this out of the way. Okay, so nice thing here is we already have 2 sides. Now we just need to figure out what the exact value of that third side is. So I have a squared, so let's say 1/2 squared, plus b squared, the one side I don't know, is equal to c squared, which is 1. So 1/2 squared is going to be 1/4 plus b squared equals 1, minus 1/4 minus 1/4. So b squared is equal to 3/4, right? Take 1/4 of a pizza away from a whole pizza, you still have 3/4 of your pizza. Square root, square root. So we're going to get b is equal to the square root of 3 over the square root of 4. I know what you're thinking, you need to rationalize, but we don't, because what is the square root of 4? It's 2. Okay, so we end up actually not needing to rationalize on this one, which is kind of nice. It's just square root of 3 over 2. So we've got square root of 3 over 2. Okay, so on my 60, 30, 60, 90 triangle, let's go ahead and put that 30 in now since we've got all the sides. On my 30, 60, 90 triangle, across from the 60 degree angle, I have square root of 3 over 2. Across from the 30 degree angle, I have 1/2. Okay, so going over to our unit circle. So this is on if you have the packet I gave you, it's the first sheet. If not, it's the more narrow triangle. So if I, again, do the same idea where I cut down here. Okay, well, we said on this triangle that this was 30 degrees. And again, the goal is to find this point out here, which we do just by going out, figuring out what this side is, and then going up, figuring out what this side is. Well, if this is my 30 degrees, we said that 30 degrees, opposite of 30 degrees, is 1/2. So then my 1/2 is going to be here. Opposite my 60, which should be up here, right, because this is my hypotenuse, That means that this last side needs to be the square root of 3 over 2. So to get to this point out here, I need to go right square root of 3 over 2, because that's this distance right here, so right here, and then up 1/2. So square root of 3 over 2, 1/2. Okay, using that same idea for this other one. I'm going to erase a little bit here. Hopefully I don't erase any lines. I'm going to get rid of this. Don't erase this on your paper. Keep that there. That's fine. But it's just going to make it easier for a second for one lecture. Okay, so instead of looking at this angle, we've got this angle down. We figured out where that point is. We also need to figure out where this one up here is going. So if I drop this down, okay, now the idea here is we want to kind of ignore this line right here. Okay, and look at this triangle. Okay, don't erase that line. We want to keep it, but that's the line we're kind of ignoring. In fact, I'm going to leave it off there for right now. So looking at this triangle, we said this angle was 60 degrees, right? Because we had the 60 up here. And across from the 60 degrees, so 60 degrees across, we had that square root of 3 over 2. So my distance up now is square root of 3 over 2. My distance to the right then must be that 1/2, because this is always 1. So then to get to the point up here, I need to go right 1.5, or sorry, 1/2, and I need to go up square root of 3 over 2. So that gives me those 2 points. So let's add those points to our circle. Well, obviously you have, but I'm going to do it on mine. Let me add some parentheses here. And we're going to use that same logic. This should be a lot faster than the last one. We're going to use that same logic. That's not going to be big enough. That's better. To find all these other spots. Okay, now I need to be careful here because of where I'm going. Okay, so this was 1, 0, -1, 0, 0, 1, 0, -1. Okay, and then we said that this was the square root of 3 over 2. This was 1/2. This was the square root of 3 over 2. This was 1/2. Okay, now, when I draw these lines, right, okay, because my triangle here came from here for this first one.